let me show you, since we're on the subject of homework number 3, what that assignment looks like. It's going to be posted on Blackboard just immediately after class, but I can briefly show it to you. Okay, so problem 1 is you are using either the factor method or the equation method to find a present value. Same thing with problem number 2, except for rather than being a word problem, we have a cash flow diagram here. And problem number 2 includes a gradient. We'll talk in today's class meeting about gradients and how to handle them. You can see that problem 3 is also a gradient problem. And then question 4 is related to using Microsoft Excel. Now, the university makes Microsoft Office 365 available to you for free. And so if you don't already have it installed on your computer, I'd encourage you to download that, get it running, because you're going to use Excel a lot through your engineering career, starting on this homework assignment in this class. And so we're going to use this built-in function that exists in Excel called the rate function. And we'll probably go over that in Monday's class. And so over the weekend, if you don't already have Microsoft Excel access, then take a moment to get that set up. All right, so that homework assignment, you've got the preview of that. It'll be loaded immediately after class, and it's due on Wednesday the 16th, so Wednesday of next week. Today we're going to be talking about interest factors and how to solve gradient type problems. Before we start on the new material, are there any questions related to the announcements? All right. Now you've seen uniform series before. This is a find P given A that's summarized in the diagram here. And remember that in a uniform series, the amounts are the same each year. So the length of those arrows is the same. And they're consecutive, meaning that there aren't any gaps. You know, if it was 1, 2, and then a gap before 3, and then a gap before we saw it in 4 and 5, well, then that wouldn't be a single uniform series. That would be a uniform series in year 1 to 2 and a different one in year 4 and 5. The point is we've done these kinds of problems before where we would use the standard notation, and summarizing the problem is P, in this case, would be a known A value multiplied by the factor. And so inside the parentheses there, we got some practice in Wednesday's class on summarizing problem types inside the parentheses. So P/A, remember, means find P given A. And that's a hint that what's going to be in the brackets is a ratio of the present value to the annual amount. And so that if you know the annual amount and multiply it by that ratio, by the factor that you can either calculate with the formula or look up in the back of the book, once you have that factor and multiply it by A, then that tells you the present equivalent. So in real world terms, what this problem is saying is you can either, well, if you deposit a certain amount of money now, how much are you going to be able to, the known amount that you want to withdraw in each of these 5 years, how much should you deposit now in order to have it be available? So it looks like this is similar to an annuity. If you've started thinking about retirement, or maybe your parents or grandparents having a retirement, one form of a retirement investment, an annuity, requires you to pay a lump sum now, and then it guarantees payouts over time. So this is an illustration of a deposit now and equal withdrawals in the future. We also saw the reverse of that, where the present value is known and what you're trying to find is an unknown annual amount. So these are annual series. This is old news. You've seen it before. The same kind of approach can be used for find A given P. P is a known amount. You multiply it by the factor that you can either calculate or look up in the back of the book, and then that would give you the A. So here is a factor table, and you can see each column has the numbers for find P given F, find P given A, but in this table there's also G. And so far you're already familiar with what P means. It's present. It's a single present value. F is a single amount in the future. A is that annual series we've just been discussing. But a gradient is something a little bit more complicated. That's what we'll talk about in today's class. When we get to the gradients, what you're going to see is that the amounts are different each year, unlike an annual series where the amounts are constant. And so you recall, I hope, that you can also find the future equivalent of a uniform series. So here you could say, if you want to take all of these recurring amounts to some point in the future, then that would be an example of a find F given A type operation. So we have the same standard factor notation, whether it's find A or find F. All we have to do is multiply the given amount by the factor. So just as a little bit of practice on these uniform series with the F and the A, before we get into the gradients, let's do this example. If we made some sort of a modification to a manufacturing process, and we're going to save money that previously was spent, that counts as a revenue. When we were going through the definitions earlier this semester, one of the categories of revenue or income is saving money that used to be spent. So in manufacturing chips, and we're saving now $10,000 per year, how much will the savings amount to in 7 years? And so that's not asking like what's the total, because that would just be 7 times 10,000. We're asking what's the equivalent amount as a single lump sum in the 7th year at 8% interest. And so this is what that problem is asking. It's saying if you know you're going to have additional revenue in the amount of $10,000 per year because now your operations costs are less than they used to be, what is the lump sum equivalent of that in the 7th year? And so this is find F given A. And so what we have to do is multiply that by the F/A factor for our 8% table. This is from the 8% table for n equals 7. Multiply the given 10,000 amount by the factor 8.9228. And so if we had just added up the amounts, 10,000 each year for 7 years, you think, oh, it's 70,000. But not so. And the reason why it's not just that simple idea is that the amount that you got in year 1 earns interest for all of the intervening years until it gets to year 7. So you're compounding that into the future. You're compounding this amount in year 1. How many years is it compounding? 1, 2, 3, 4, 5, 6 time periods to get it to the 7th year. And so then this $10,000 only is going to compound 5 years. And this compound 4 years into the future. And so all of that compounding effect is taken into account when we want to find the lump sum future value equivalent of it. Any questions on this illustration? Okay. Oh, was there a question? All right. Now here is the gradients that I've been mentioning a little bit so far. A gradient is such that instead of the amount is constant every year, it's a gradually increasing quantity in each successive year, and the gradient changes by the same amount each year. Or, if the periods are month or quarter, the point is that in each period, the total amount increases by G. G is the value of the gradient. And so what's illustrated here is this hypothetical of How much should you receive today in order to be able to pay out in the first year? No money. You don't have to pay anything out because the form or the convention for this gradient is that in the first year you have 0 times whatever the fixed amount is. And then in year 2, you have 1 times G. In year 3, you have 2 times G. And so this is one of the common mistakes and stumbling blocks I see students kind of struggling with, is remembering that in year 1, there's actually no effect from a gradient. You don't actually observe the effect of the gradient until the second year. So here the note says that the gradient starts at the end of year 2. Okay, so in the in-class exercise that we have accompanying today's class meeting, if you have printed those off, then let me show you. Just as a refresher, we're going to start here on problem 1. Now, I've included the formulas and also the 8% factor table. So I got a question via email earlier this morning about what formulas you should use. You know, for example, if you're going to do a problem where you want to find P given A. Well, this column is the formulas for the ratios that are defined here. So, for example, F divided by P is 1 plus I to the N. A divided by P is 1 times I times 1 plus I to the N in the numerator, and here's the denominator. So this is basically an equation sheet. And I'm going to give you this equation sheet to use along with the exam, and I'll also provide the factor table that you'll need on the exam questions that you're going to have. But you need to be able to see this as the equation sheet that it is. All right, so on problem 1, you have the flexibility of using either the factor table or you can use the equation method, and we want to find out if you give a $7,500 loan at 8% interest that should be repaid in equal annual amounts over 8 years, then how much should each of the annual repayments be? All right, so let's pause for a moment to do that kind of refresher, and then we'll actually, in the second problem, sequentially step through some of the ideas having to do with a gradient. So if you finished problem 1 really quick, you can go ahead and jump ahead to the second one. All right, so anybody got a guess for that first problem? Or not a guess, you don't do guesses, you do calculations. So how much should each of those annual repayments be? Good. Okay. So remember, it's a important thing to be summarized this according to the standard notation that we follow. So P is 7,500, I 0.08, N equals 8. And so then when we fill that in, inside of the parentheses, we include the labels just to make it clear what's going into the first field as an interest rate, what's going into the second field after that is the number of periods. And of course, this is a find A given P type problem. Now, going this step-by-step route and not just writing the answer on the paper, making it sequential, allows the grader, whoever it is, to give you more points if you end up in a partial credit situation. So I did this one by the table lookup method, and so let's find, this is the 8% table, and N equals 8 means it's going to be this row, and we're looking for the A/P column. So here is the factor that you multiply 7,500 by. And if we had decided to use the equation method, so this is find A given P. Let's go find the equation for that. Find A given P. Here it is. So this is the formula where you would substitute I as 0.08, N is 8, and then you would get an answer that would allow you to report to the nearest penny. Here I've rounded off to the nearest 10 cents because my factor that I looked up out of the factor table only had 1, 2, 3, 4, 5 digits. And so then that means that my final answer that I had in my calculator needs to be rounded to the 1, 2, 3, 4, 5th digit of significance. And so that's to the nearest 10 cents. All right, so that was the first problem. Any questions before we move on from that one? Okay, now, gradients. This is where things get interesting. Oh, wrong one. I don't want to show you the answer yet. That's the homework. I'll get there eventually. All right, in-class exercise. Oh, geez. All right, so here is our second problem. And just to reinforce in your mind, like what is the typical sequence for a gradient, I'm giving you a cash flow diagram, and you'll notice that there's no numbers on it yet. I haven't added the years to the tick marks because I want you to, by writing that in, writing the years on the cash flow diagram for part A, that will help you to see that in year 1, there's nothing happening from the gradient because G equals 0 in year 1. And then you have 1G that occurs in the second year, 2G that occurs in the third year, and so on and so forth. So go through this process, see how far you can make it, and then it says here in part C that you should use the table, the 8% table with the P to G column. So if we go back to the 8% table, here is the P to G column, the gradient present worth. So you'll use that for part C of the question, and then part D, you need to use the equation, the F/G equation, because we're going to find the future value in year 4. So the F to G equation is this one, the one at the bottom. Find F given G. All right. So hopefully you have this printed out. If you haven't yet printed it out, let me know. I'll print it for you. At this point, it's really, you know, it's important to have these printed out. So if you don't have access to a printer, you can't afford getting them printed out, then let me know and I'll print a set of the in-class exercises for you. All right, I'm going to pause for now and give you a chance to start working through this problem. All right, so the part A and B is that in part A, you should write the years on the cash flow diagram. And so you can see, you know, 0 is the first tick mark indicating the present, then 1, 2, 3, and so on. Time continues even when there isn't an amount in the cash flow diagram. So I numbered years 5 and 6. And that doesn't mean, just because the cash flow diagram continues, that doesn't mean that you're going to need to find future value in year 6. It says in the problem statement to take it to year 4, but there are occasionally going to be cases where you look at a cash flow diagram and the cash flow diagram is much longer than the actual amounts that are indicated. and that's fine. It doesn't mean that you need to take the future amounts to the end of the cash flow diagram. Just time continues on whether or not the amounts do. So then n equals 4 and g equals 200. And the reason why g is 200 is that every successive year, an additional $200 is added to the series. So g is 200. So now in part C, find the present value using the table and the future value using the equation. And I'd love to see your guesses or calculations in the chat box. All right, let me show you the solution to part C, and hopefully you have ended up with the same thing, the same factor. All right, so we're going to use the factor 4.6501. And so that came from the table here. And we're going to find the present value of a gradient where we know g is 200. So g is known, p is unknown. So that means we're going to use the gradient present worth. And if we go down to n equals 8, so n equals 8 is here. And so the factor 4.605, I'm sorry, I was looking at the wrong problem. So this is 8% interest, but n equals 4. All right, so 4.605 is there. Okay, so P slash G, n equals 4, 4.605. So when you have the factor and then multiply it by the known $200 is the value of the gradient, then that is where 930 and 2 cents comes from. And this time we can be accurate to the nearest penny because in the gradient there's 1, 2, 3, 4, 5 digits of precision in our factor, and so then that's 930 and 2 cents. So that's 5 digits of precision as well. So what we've done is we've taken each one of these amounts to the present and combined them together. So the $200 was discounted 2 years at 8%. The $400 was discounted 3 years at 8%. And the $600 was discounted 4 years at 8%. So you could solve this another way. The brute force approach would be to find P given F for each of the individual amounts. And if you had done that, you'd end up with 930. It may not be accurate to the nearest penny, but it would be awfully close. All right, now find the future value in year 4. Now the form of the future value when it comes to a gradient is that the gradient is going to be in the same year as the last amount that you see. And so it's going to be taking it it's going to take the $200 from year 2 to year 4. All right, so if we were going to do this the brute force approach, then it would be $200 compounded 2 years into the future, $400 compounded 1 year into the future, and then combined with the 600, and the 600 wouldn't change amount at all. But we're going to do this using the F slash G equation. So here you can see the substitutions that I've made to find the factor. So we start off with the equation itself. So the equation in the F slash G is here. That's going to be on the right-hand side of the equation, and on the left-hand side equation is F divided by G. So F divided by G on the left, and on the right, that 1 plus I to the n minus 1 divided by I squared. And you can see I've done the substitution of the amounts and then found the resulting quantity in the first term on that side of the equation. So 56.3264 and then minus n divided by I. So that is 50. So then the result is 6.3264. So we're going to multiply 200 times that, and then it will give us 12,065 and 28 cents. So that is the same as if we had compounded the 200 2 years into the future, 400 1 year into the future, and then combine it with the 600 that was already at year 4. So the amount that's already at year 4, that 600, it doesn't need any compounding because it's already in the future if we're doing it the old-fashioned way, treating the amounts as individual quantities. All right, so are there any questions on that first gradient problem? The second one's a little more tricky because in the cash flow diagram, there's both a gradient and also an annual series at the same time. They're on top of each other. So take a look at this cash flow diagram. You can see that in each year there's 400, but then on top of that 400 in each year, in year 2 there's an extra 30. Then in year 3 there's 2 times the gradient, so that's 60. And then year 4 there's 3 times the gradient amount, and so on and so forth. So we have an annual series and a gradient. So here in part A, what I'm asking you to do is sketch it differently. Sketch it, first of all, do a sketch of the annual series, and then to the right of that, sketch the gradient. So right now it's 2 cash flow diagrams combined. I'm suggesting if you separate them apart, then it'll help you to see the 2 pieces of this problem a little bit more clearly. So do that sketch. Write these cash flow diagrams again on the paper there. Write the gradient component of it and the annual series component. All right, so this is what the deconstructed cash flow diagram should look like. All right, so on the screen I have illustrated what happens when you take the cash flow diagram and turn it into its constituent gradient and annual series components. So we're going to find the present worth of each of those separately. So you can see that there's the base of 400 every year. And so that's an annual series starting in year 1 through year 5. So we want to find what's the present value of the annual series component, and then what's the present value of the $30 gradient component. So then the sum of those 2 P's together, the P from the annual series and the P from the gradient, is the combined total present worth of each. Okay, so here in part B, I'm saying find the present worth of the annual series, find the present worth of the gradient, and then find the combined total present worth of both. So I didn't give you the 12% table, did I? So with not having the 12% table, then that means you're going to need to use the formulas. So let me scroll back up to the formulas and paste it down on that other page. So we're going to be doing the P/A and the P/G. All right, so let me copy this and paste it down so that you can see both at the same time. Harry's got it. Okay, so Harry weighed in with the correct amount of the present value due to the annual series component. Let's look at the present worth of that part of the solution. All right, so this is on the Josie. Have more confidence in yourself. That's the correct P to G. Good. 2 of you got it right. Excellent. Oh, yep. Good. Cupcakes for everyone. Okay. All right, so here is how we do the P to A part. All right, so the formula that we use for find the present value of an annual series, I is going to be 0.12, N is 5. So you can see I've done the substitution here into that formula, found the result of the numerator, and then the dot, dot, dot means that even though I've only written 4 digits in the numerator, actually I kept all of the precision in my calculator, and the same thing with down here in the denominator, so that this factor is accurate enough that when I multiply it by the 400, I'm going to be able to report my answer to the nearest penny. So $1,441.91 is the present equivalent of the annual series component of this cash flow diagram, because we deconstructed it into 2 pieces. And so far we found what's the present value of just that recurring 400. So now the next part is what's the present worth of the 30, 60, 90, 120 starting in the second year. Okay, so the formula for that you can see is a little bit more complex. And we've done the substitutions here. Let me give you a moment in case you want to glance at that and take it all in its numeric majesty. So this incremental approach of showing, what is the result of the substitution in each the numerator and the denominator, the first term and the overall second term, just kind of seeing what's the magnitude of each, keeping track of the reasonableness of the solution before you just take it as faith at the very end. So as was mentioned in the guesses, the ratio of P to G, 6.3970, and so then that means if you multiply that by $30, then the present value of the gradient part is $191.91, which means the total, if you add together the amount that came from the annual series plus the amount that came from the gradient, then the total is $1633.82. All right, so looking back at the homework assignment, I think I've maybe closed that now. Is it acceptable to use the table lookup factor? The question, if the question doesn't show you. Yeah, sometimes the question won't tell you which way to use it. For example, here on the homework it says use the equation method. This one says it's your choice. Sometimes I won't tell you either way. So this one says use the factor method. But later in the semester, we'll get to the point where I'll just ask you the question, but I won't tell you which way you have to solve it, and then it's whichever way you prefer. So if you want to get started on that homework assignment, it's going to be the next thing I do is upload that. It'll be available on Blackboard from now until 11 o'clock on Wednesday. That's all I have for you today. Hope you have a great weekend, and I will talk to you on Monday. Bye-bye.